For the test 3 wrapper, I'm going to go over question number 1 from test 3. The question states that there are 3 bulbs connected as shown in the diagram. There are 2 round bulbs and 1 oblong bulb. We have to find the current flowing through the oblong bulb. The question, to solve the problem, we aren't going to need a lot of laws or anything. We're just going to use Ohm's law and the 2 rules to determine the effective resistance when a circuit is connected in parallel and when a circuit is connected in series. So from the problem itself, we know that the resistance of a single round bulb when it is connected to one of the batteries of which produces an EMF equal to EMF, then the resistance is equal to EMF over IR, where IR is a given value. Similarly, for the oblong bulb, we know that IO and EMF, then that resistance equal to R over there. Step 2, we need to determine what's the resistance through the parallel part of the circuit, which is there. Using this rule here, we have this 1 over R parallel is equal to I over EMF plus IR over EMF, which after solving is equal to this. Step 3 would be the effective resistance of the circuit, that is the series that's with this bulb and the parallel over here. So we just add those 2 resistances over there like that, and we get the value which is equal to this. It looks kind of complicated, but then it's going to cancel out eventually in the problem. So step 4, the current throughout the circuit. Again, using Ohm's law, we have I is equal to V over R, and V is equal to 2 times EMF, since there are 2 bulbs in the circuit, 2 batteries in the circuit. So 2 EMF over the resistance that we calculated over there, that 2 EMF over that, or the resistance, which after simple algebra gives us this 2 IR times IO plus IR over 2 IR plus IO. Step 5, we need to determine the potential difference across the parallel connections. That is, what's the potential difference through the circuit when we go from this point to that point over the area. So potential difference is equal to I times R, and the current throughout the circuit when it's in parallel is constant. So this is the current that we use, and RP, which we calculated in step 2, and then we get this value here since the EMFs cancel out, and we get the potential difference across the parallel connection is equal to this. And finally, through the current through the oblong bulb, when two resistors are connected in parallel, they have the same potential difference over each other, but different currents flow through the different parts of the circuit. So the potential difference that we calculated over here is going to be used here again, simply using Ohm's law. So it's potential difference times resistance is equal to current, and that's the final answer there, 2 IR times IO over 2 IR plus IO. I hope that was helpful. Thank you.